Hello guys, so welcome back to our week 3 lectures. In this lecture, we're gonna look at the internal structure or component of the CPU, the processor, and also we're gonna highlight with a basic example how the computer computes, how the processor computes or process some instruction. Then later in other videos, we're gonna introduce you guys to the assembly language. So this is basically a very fundamental video for the next video. So let's start. So what is basically the main component that the processor depend on to process or to execute some instruction? The basic or components are are shown here in this figure, and we're gonna look at them one by one. The first component is registers. So usually processors, they have what's called registers, and registers are used to as like a temporary storage. So when you have some data that you're going to process, like a number, for example, usually you put this number in these registers, and usually you have many registers. Like for example here, this is a hypothetical example. You have here a processor with 4 registers, register A, B, C, D. This is different from our CPUs, which is Intel CPUs, x86. But this is just a hypothetical example, as I said. Okay, and the size of each register is dependent on the design. So you might have a processor with 8-bit registers, or 16-bit register, or 32, or maybe 64. So it depends on the. So you must, for example, read the data sheet or the the information about your processor to know what size your registers have. Okay, the second component is what's called the program counter. So the program counter, by the way, is another register, but this register usually have some value. This value basically point to the instruction or the next instructions that the computer will execute. So usually, if you have a memory like this, your program is stored in the memory. And the memory is usually, as you see here, guys, is a sea of locations. You have many locations here in this memory. So you might have an instruction here, another instruction here, another instruction here. So the computer needs, or the processor needs to know which instruction I'm going to execute. So that's why we have this program counter, or sometimes it's called instruction pointer. Both are the same. So if it's targeting this location, that means next time the processor will execute some instruction, it will execute that one here. After executing that, this program counter will increment and go up to point to the next instruction, and so on and so forth. This is also very basic, component in any processor, actually. The third component is basically the instruction decoder. So the computer or the processor can execute, many different kind of instructions. Like for example, it can add, it can subtract, it can multiply, it can divide. Okay, so whenever we fetch some instruction from the memory, we need to know what is the meaning basically of this instruction. So we need what's called the instruction decoder. So this instruction decoder will read the instructions that came from the memory, and it will tell the processor, oh, this, for example, this is an addition, so you must use, for example, this part of the processor, or this is subtraction, so you must use this part. This is multiplication, you must use this circuit, and so on and so forth. The fourth module here we have is the ALU, Arithmetic Logic Unit. And the name tells. So arithmetic logic units, it's a module, a circuit, basically. It's a circuit, that do arithmetic operations and as well as logic operations. You can do their add, subtract, multiply, division, whatever arithmetic you have. And also you can do logic operations like and, or, not, and, nor, whatever. Now we're going to look at how a computer computes basically, how a computer executes an instruction. So we're gonna continue with our processor, hypothetical processors that have 4 registers, A, B, C, D, okay? And imagine together, you know, a program. This program, you know, stored in the memory, and this program will basically move some value to a register, then add to this value another 2 values. Basically, what we want to do, we have our register A. First, we're gonna move to this. So this is the register A. We're gonna move to this register a value which is 21 hexadecimal. Then we're gonna add to this value 42 hexadecimal. Same register. So this value will change, the 21 will change hexadecimal. Then we're gonna add again another value, which is 12 hexadecimal. So again, this value will change for the second time. Okay, so series of instructions. So I am telling here I am instructing my computer, hey computer, put 21 hexadecimal in register A, add to this value 42 hexadecimal, then add again 12 hexadecimal. So 3 instructions. So let's see how a basic computer should do. What is the intuition? You know, what is the basic idea that any computer, any processor basically can do to execute such basic instructions. So we're gonna assume, of course, we said that, you know, computers understand only zeros and ones. Okay, so you should imagine that these instructions are basically stored in the memory in a form like 0 and 1. And here is the code for each. So there is a code, a binary code for each instruction. So here is the code for the move to A. This is the code for the addition, add to A register. And this is again same instruction. So it's again add to A. This is an instruction itself. So I'm saying in the first one, move to A. So I need to know move what. So we need the data. The second instruction means add to A. So I need again to know what number I should add to the value in A. So we need also a data here, which is 42. And also in the third one, it's similar to the second. I'm telling the processor to add something to A. So the processor needs to know this number, new number. So we need also a data here, a piece of data. Okay. So we should imagine now that our instructions or our memory that have the instructions should have the instruction code and also some data. And here is, you know, what this will look like. We're gonna, you know, imagine here a memory like this. This memory is big. I'm just gonna draw the part that we are interested in. This part composed of, you know, 1, 2, 3, 4, 5, 6, 7 locations, okay, which have our instruction codes and also the data that we're gonna add or move. So it's mentioned here that this memory has 16 address bus. So that means you have a memory like this, and this memory has 2 to the power 16, you know, locations, which is very big. Okay, so the first location should be 0, 0, 0, 0 hexadecimal, and the final location should be 4F hexadecimal, which is, you know, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 in binary. This is 16 bits. This is the maximum location. And we should imagine that our, you know, program should be somewhere in in between here in 7 locations. That's what we exactly have here. Okay, 7 locations. So the first location here has B0, which means move something to A. This thing that we're gonna move is stored in the next location. So this is the data. This is the move instruction. So this is another instruction, means add, and this is again data. This is another instruction, add, and this is again data. And this one is really interesting here. We need to tell the computer that we stopped. This is our final instruction. So this is basically called halt. To stop incrementing the program counter. The program counter, which points to the next instruction, always incrementing, always incrementing. So after we execute our 3 instruction, we want to not to execute anything further. So we need to put this halt here. Okay. Again, this is a memory. So the last location in this memory here, as we said, is if hexadecimal. The first one is 0000 hexadecimal as well. Okay. So we're gonna imagine that this location here has an address which is 1400 hexadecimal, 1401, and so on until 1406 hexadecimal as usual. So let's see how the computer will execute all these instructions. That's very interesting. So basically, the first step, we need to know, or we need to put the instruction pointer at the, at the location or the start of our program. So we should imagine that the instruction pointer is pointing to this location here, 1400 hexadecimal. So when the computer fetches or grabs this instruction, it will grab it from the location which is pointed to by the program counter. So in the beginning, the computer will fetch, or the processor will fetch this code B0. So it will read, B0. B is, I think, 1101, and the 0 is, this is of course a decimal number. So it will bring to the computer something like the processor, something like this. This means move to A, move some number to A. Okay, so after fetching that one, and the instruction decoder will interpret this code to the computer. Hey computer, this means you should add something to A. So this means, since this is only a code in instructions, we should go to the next location, and this next location should have our data, our numbers that we should move to A. And that's what's going to happen next. That means we grab the complete instructions. It's an instruction part and data part. And now the program counter should point to the next location, 1402 hexadecimal. So once the data moved, the computer will move to this new location, 1402, and grab the next instruction. Again, when the computer grabs the next instruction at 1402, the instruction decoder will interpret that code, which is 04, to the computer, which means, and the computer will understand that this means you should add something to A, some number. Where is this number? This number should be in the next location. So it will grab it from the next location, which is 42. So it will add 42 to 21. So A equal to 24 plus now 42. Of course, this all is hexadecimal. And since we now, since we read 1402 and 1403, we read the whole instruction. So the program counter will point to 1404. So once we finish processing that addition, we go and fetch what's written in 1404. Once we finish the first addition, the program will go 1404 and grab the next instruction, which is again 04, which means add something to A. Where is this number? This number should be in the next location. So the computer will grab this new number, so it will add 21 plus 42. This is the old value once we reach it here, and then it will add another value, which is 12 now. All that is in A. And once we bring the whole instruction, we move the instruction pointer to the next instruction, which is 1406. And 1406 is our halt instruction, which means, you know, this is the end. So halt incrementing or pause incrementing the program counter. And this will end, you know, this routine basically, or this code. Okay, guys, that's it for this part. Thank you very much for watching, and see you in the next video. Bye-bye.